Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting presentation for DTC P2122, which stands for APP Sensor A, TP Sensor D Circuit Low Voltage, in the Honda Civic models from 2011 to 2015. This error code is associated with the malfunctioning of the Accelerator Pedal Position, APP Sensor A, which plays a crucial role in providing throttle position information to the Engine Control Module, ECM. The APP sensor, typically located on the accelerator pedal assembly, sends voltage readings that the ECM uses to regulate the engine's throttle response. When the sensor's voltage drops below acceptable levels, it triggers the P2122 code, indicating a potential electrical issue with the sensor circuit. Proper diagnosis is critical, as ignoring this code may lead to poor engine performance or drivability issues. Error code P2122 indicates a malfunction of the APP Sensor A, which is essential for throttle control in the Honda Civic. This sensor is situated in the accelerator pedal assembly and is responsible for detecting the driver's input and sending corresponding voltage signals to the ECM. The APP Sensor A operates in tandem with other sensors to ensure smooth throttle response. When the voltage measured from this sensor falls below 0.2 volts, it signifies a potential failure in the circuit, prompting the diagnosis of DTC P2122. To effectively troubleshoot this code, one must locate the APP sensor within the vehicle, typically positioned around the accelerator pedal. Checking the voltage and connectivity in the sensor circuit is critical for clearing this error. Several possible causes could lead to the P2122 error code in the Honda Civic. First, poor connections at the APP sensor or the ECM may lead to incorrect voltage readings. These connections can become corroded or loose over time, causing intermittent failures. Another potential issue is an electrical short or an open circuit in the wire connecting the APP sensor and the ECM. Such faults can disrupt the voltage signal sent by the APP sensor. Lastly, a malfunction within the ECM itself can also trigger this error code, particularly if the system software is outdated or corrupt. Understanding these underlying causes is essential for effective diagnosis and repair. The symptoms accompanying DTC P2122 can significantly affect the driving experience in a Honda Civic. The most common indicator is the check engine light illuminating on the dashboard, alerting the driver to a malfunction. Additionally, drivers may experience poor throttle response, where the car does not respond effectively to accelerator pedal inputs. This can lead to situations where the engine may stall unexpectedly, posing a safety risk. Furthermore, reduced acceleration may occur, making it difficult to maintain speed or merge into traffic. Recognizing these symptoms early can help in taking prompt action to address potential issues before they escalate. The first step in troubleshooting DTC P2122 involves verifying the problem. Start by turning the ignition switch to the on position, which powers the onboard systems without starting the engine. Use the Honda Diagnostic System, HDS, to access the data list that specifically shows readings from the APP Sensor A. Here, you're looking for the voltage output from this sensor. Ideally, it should be around 0.2 volts or less. If the voltage is at this level, then the failure can be confirmed, and you can proceed to the second troubleshooting step. However, if the voltage readings are normal, this indicates an intermittent failure, suggesting that the system may not be faulty at that moment. In this case, it is recommended to check for poor connections or loose terminals connecting the APP sensor to the ECM. In Step 2, the objective is to determine the possible failure area by checking the voltage supply to the APP sensor. Begin by turning the ignition switch to the lock position to ensure safety before making any electrical connections or disconnections. Disconnect the APP sensor 6P connector to isolate the sensor from the circuit. With the connector removed, turn the ignition to the on position again. Then measure the voltage between test points 1, number 5, blue wire, and 2, number 6, BRN wire at the APP sensor connector. At this point, you should expect a reading of around 5.0 volts. A successful reading confirms that the power supply to the sensor is intact, allowing you to move on to step 3. If the voltage is absent, this could indicate a fault in the VCC4 line or open circuit. Step 3 focuses on checking for any shorted wires in the APS1 line. After turning the ignition to the lock position, jump the SCS line using the HDS to prepare for the continuity check. Next, disconnect ECM connector A, 49P. With the APP sensor connector still disconnected, you will now check the continuity between test points 1, APP sensor 6P number 4, YL wire, and 2, body ground. This test should be conducted with the ignition in the lock position to ensure safe testing. If there is continuity, this indicates a short in the APS1 wire between the ECM and APP sensor, necessitating repairs. However, if there is no continuity, this suggests that the APS1 wire is intact, allowing you to proceed to step 4 for further investigation. In step 4, the focus remains on the APS1 line to check for any possible open wires. Begin by connecting the terminals A, APP sensor 6P number 4, YL wire, and B, body ground, using a jumper wire. This connection mimics a completed circuit, allowing us to test continuity effectively. With the jumper wire in place, you must verify the continuity between test point 1, ECM connector A number 28, YL wire, and test point 2, body ground. Conduct this test while keeping the ignition in the lock position and ensuring that the APP sensor is still disconnected. If continuity is confirmed, the APS1 wire is good and you can move on to step 5. However, if continuity is absent, it indicates an open wire issue that must be repaired between the ECM and APP sensor. Step 5 is crucial as it involves examining the internal circuit of the ECM. First, reconnect the ECM connector A, 49P that was previously disconnected. Next, with the sensor still disconnected, create a jumper connection between terminals A, APP sensor 6P number 4, yellow wire, and B, APP sensor 6P number 6, burn wire. After establishing this jumper connection, turn the ignition switch to the on position once again. Utilize the HDS to check the APP sensor A data in the system. A voltage reading of 0.2 volts or less at this stage indicates a problem with the ECM, perhaps requiring a software update or substitution with a known good ECM to rectify the issue. If the voltage is above this threshold, it is advisable to replace the APP sensor. Each of these steps is integral to properly diagnosing and correcting the P2122 error. In step 6, the investigation shifts to check the integrity of the VCC4 line. Start by ensuring the ignition switch is in the lock position to maintain safety. Then, jump the SCS line using the HDS as previously done. Next, disconnect ECM connector A, 49P, to stream down the circuit tests. Create a connection between terminals A, APP sensor 6P number 6, brown wire, and B, body ground via a jumper wire. With the ground connection made, verify continuity between test point 1, ECM connector A, number 36, brown wire, and test point 2, body ground, while the APP sensor connector remains disconnected. If continuity is present, the VCC4 wire is functional. However, if not, this suggests an open circuit that requires immediate repair between the ECM and APP sensor. This step is vital to ensure the complete integrity of the circuit related to DTC P2122. The final step in the troubleshooting process for DTC P2122 involves verifying that all repairs have been executed correctly. Start by turning the ignition switch to lock and ensuring all previously disconnected connectors are reconnected securely. Once all connectors are back in place, turn the ignition to the on position. Utilizing the HDS, reset the ECM to clear any stored codes and reinitialize the system for proper functionality. Following the reset, perform the ECM idle learn procedure to ensure that the system adapts to any changes made during repairs. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P2122 is indicated indicated, it may point to poor connections or loose terminals at either the APP sensor or the ECM, and additional verification may be necessary. If no issues are present, this indicates successful troubleshooting. For long-term vehicle reliability and to prevent the recurrence of error codes like T2122, proper preventive maintenance is crucial. Regularly inspecting electrical connections, particularly those related to the APP sensor and ECM, can help identify and rectify potential issues before they cause serious faults. It's also important to keep the ECM updated with the latest software versions provided by Honda, as older versions may not function optimally with newer vehicle specifications. Additionally, checking for corrosion at connectors or wiring can prevent electrical failures in the future. These proactive measures ensure not only the longevity of the vehicle's components, but also a safer and more efficient driving experience. In conclusion, DTC P2122 signals a critical issue with the APP sensor circuit in the Honda Civic, and proper diagnosis is key to resolving this concern. This diagnostic process highlights the importance of checking both wiring integrity and connections. Each troubleshooting step provides valuable insights that direct technicians toward pinpointing the fault, whether it involves shorts, opens, or issues within the ECM. Regular vehicle maintenance and inspections can greatly enhance the reliability of the APP sensor system, reducing the likelihood of encountering this error in the future. Understanding these concepts enables owners and technicians alike to maintain optimal performance in Honda Civics, ensuring a smooth and safe driving experience. Please like and subscribe to the channel. See you next time.